parallel lines?
Parallel.
We raise our hands. We can't all yell at the same time. All right. Ashley.
Parallel lines are lines that never touch, ever going horizontally.
Okay.
Or vertically.
Okay, so she's saying they have to be vertical, horizontal, and they can never touch. Let's elaborate on that a little further. What else we've got? Okay, Bria, what'd you just do? She goes, they can go diagonal too.
Oh, true.
They can. They can go in any direction, right? Direction's not important just as long as they kind of run side by side. Okay? So now if they're running side by side, no, that would not be parallel.
I know.
What's that?
Intersection.
That's intersecting. We'll get there in a second. Okay?
Don't steal it.
Hey, okay, so we have parallel lines, right? Running in the same direction. What else does anybody know anything else about parallel lines? There's some very important things about parallel lines. Say it again. What do you mean a shape? They can be in they can, rectangles and rhombus. Yeah, all those words from this summer are very good. However, we're not looking at shapes. We're literally just talking lines because that's all we've been studying.
The degrees and angles.
Say that again?
Are we talking about degrees and angles?
No, you're talking shapes and we're not doing shapes yet. Okay, we're literally just talking about two lines. Okay, so let's go ahead here. You don't have to write any of this down, just kind of look up. So if I look at this guy, you guys agree, have at least told me, that they have to run side by side, right?
No cross.
Okay, we're never going to cross. They're going to run side by side like railroad tracks or whatever you want to think of, okay? So now, let's think about in terms of M's and B's, because that's what we've been studying anyway. B values. First off, when I say B, what am I talking about?
What's your start value?
Start position on the y-axis, also known as the y-intercept. Very good. Okay, so if I'm looking at these two start positions, are they the same or different?
Different. Different.
Different, right? Okay? They should be different, okay? If they weren't different, then they'd be sitting on top of one another, okay? They'd have the same start spot. But they're different, okay? Now let's think about their slopes, okay? If I want them to never ever cross, what's going to be true about slopes?
Their slope's going to be the same.
They would have to be the same. All right, so if I go up 1 and over 2 here, I better go up 1 over 2 here and keep that pattern going so they run side by side. Okay?
Down that way.
Yes, we know that we can go up and down or down and over. It's okay. It's all the
No,
same.
I was just saying would that not make a difference?
No, you can go up 1 and over 2 or down 1 left 2. It's all the same stuff.
Yeah.
We've been working on lines for a while now.
No, I was just thinking it would never intersect. Why would you never do it?
It has to be the same slope. If you start changing your slopes up, if I change my slope, doesn't that change the steepness of the line?
Yeah.
So then if I start changing the steepness of the line, now all of a sudden they start intersecting. So the only way for them to stay parallel is to have the same slope. Okay? So parallel lines. Lines that never intersect. Okay? And the big dog. They have the same slope. Okay? So lines that never intersect, and they have to have the same slope. I cannot stress this enough. You will have to know that. Okay? They have the same slope. They're parallel. Okay? I think writing down that they have the same slope is really important right there. All right, so on the first set here, it says slope-intercept form. Okay, I'm just reading directions here, so help me out. What's slope-intercept form? Ben?
Y equals mx plus b.
Okay, so we know that it's going to look like y equals mx plus b for my final answer. That's what we want. Okay, slope-intercept form of an equation of a line that passes through the point. So they're giving you some random point here, like -1, -2, and is parallel to this other line here, okay? So let's take a look at what we're talking about here, okay? And you don't have to draw this, but just kind of pay attention to it so you understand exactly what's going on here. Okay, so if we're looking at these two guys right here, okay, I have got a random point in space, -1, -2. So -1, right, -2. So this random point, nothing else, just a point. And then I have this line, okay? How do I graph this line? Now you just start us off. Negative 3x minus 2. Good. Start on negative 2. And then how do I do negative 3? Okay, very good. Down 3 and then to the right 1. Okay, and so then I can take it up 3 and to the left 1 if I wanted. Okay, so here's my line. It's not really the best, but you kind of got the idea there. Okay, so now I've got this line, and what they want you to do is they want you to find the line that is parallel, but it has to go through that random point they gave us. So you're going to write an equation of the blue line. That's your job today. Okay, does that make sense? Okay, so let's think about this. To write an equation of the line, what are the 2 pieces of information that are helpful? If we already have a point, what else do we need? Slope, right? Point and slope. And we can write equations of anything for a line, okay? So if I'm looking here, what's my slope?
Negative 3.
Negative 3, okay? So if I'm looking at this guy right here, okay, I am going to pick this guy out. This is my slope. We know slopes have to be the same. Okay? So I am pulling out negative 3 out of this guy. And guess what? The rest of it we throw out. We don't care about it. The only thing we're using that equation for is slope only. We are using it and throwing it away. Okay? So we pull out the negative 3. And then we have the xy coordinate point. Guess what you can write now?
Slope.
1 and 2.
I mean the y.
If you have a point and a slope, we can write
Point slope.
point slope. There we go. All right. So y minus, all right, your y value, negative 2, equals your slope, negative 3, x minus negative 1. Is everybody okay with that? We've been working on this for a while now.
Yeah.
Okay, so now then again, these are going to become pluses, right, in the middle. Okay, now it said slope-intercept. So what are some things that need to happen to get this into slope-intercept? Distribute. Okay, good. So we're going to distribute the negative 3 through. So y plus 2 equals negative 3x minus 3. All right, what else needs to happen here? Subtract 2 over. It's a plus 2, so we're going to subtract 2 over to the other side. So those 2's will cancel, and we get y equals negative 3x, that's right, minus 5. Okay, now is that the right form? Is that what they wanted in?
Yeah.
Yep, so we're done. There's our answer.
That was easy.
I know. Once you know point slope, you can do a lot of things.
This is way much better than point slope.
Yep. Okay, so I want you to try B on your own now. Just like A, try B on your own.